Continuing on with our discussion of Java thread features, we've got a two-part lesson here that talks about types of Java threads. If you recall before, we talked about something called daemon threads. We're going to talk now about what types of threads there are, and you'll get a chance to learn more detailed what a daemon thread is. So there are two types of threads in Java, user threads and daemon threads, and you can choose which one you want to allocate. A user thread is a high priority thread. That's kind of a funny term. It's high priority relative to daemon threads. And the Java execution environment will wait for all user threads to complete their tasks before terminating the process. So if you have a process with 4 user threads in it, then when all 4 user threads have terminated, then the process will terminate. And by the way, the default thread, which is typically called the main thread, is a user thread. So when the main thread goes away, if there's no other threads that are user threads, then the process terminates. If there are other user threads that are still running, the process does not terminate. In contrast, a daemon thread is a low priority thread. And its only purpose, or their only purposes, because there's sometimes more than one of them, is to provide services to user threads in the background. We're going to take a look at an example here called user or daemon thread, and I'll walk through that example and show you the differences between user threads and daemon threads. When a Java program starts, if you just start running a program, however you run the program, you run it from IntelliJ or the command line or whatnot, console window, it contains one and only one user thread. It contains a single user thread. This is the main thread, so I marked it with an M for main. And if you take a look at kind of the diagram for a Java program, this kind of shows you what you can have. You have a Java program, it has a main thread, which has a stack, and then the main thread can create one or more other threads. So these other threads can either be created by the main thread, or the other threads can create threads themselves, for that matter. So you can have a hierarchy of threads. User threads and daemon threads differ in what happens when they exit. So let's assume, for sake of argument, we have a process with 4 threads. We have a main thread, which is a user thread, and 2 other user threads, and then we have a daemon thread, which I put a little daemon in there. The life cycle of a user thread can outlive the life cycle of the main thread. So if the main thread terminates, either normally or abnormally, it goes away, these other threads will keep running because there's at least one other user thread that's still alive. However, when all the user threads go away, the daemon thread or threads automatically terminate. So their lifetime is bound to the user threads. It's like Sauron in Lord of the Rings. His lifetime is bound to that of the ring, right? So when the ring goes away, Sauron goes away. So when user threads go away, the daemon thread goes away. Actually, that's a great analogy because Sauron's kind of like a demon, right? So his lifetime is bound to the ring. So when all user threads have exited and any remaining threads are all daemon threads, then the Java program will also exit. And the reason for this, if you're curious, is that we want daemon threads to be providing services for user threads, but users typically don't know they're running because they're often being spawned by a library in the background, like the common fork join pool. And as a consequence, the user didn't create them, so the user would have no way of knowing to shut them down. But we don't want the program to hang indefinitely waiting for those daemon threads to shut down because they don't know any better. They won't shut down unless they're automatically shut down when the process goes down. Now, another thing to remember is if a thread calls runtime exit, that will unilaterally terminate the current Java execution environment by initiating a shutdown sequence. So you can also shut everything down without waiting for the other threads to exit just by saying runtime exit. Yes, sir. Good question. So the question is, if there's a main thread and a daemon thread, what happens? So as long as the main thread, which is a user thread, continues to run, or let me rephrase, has not terminated, then the daemon thread will still be around. But if the main thread were to go away, the daemon thread would automatically go away. The inverse is not true. If the daemon thread exits, that won't affect the main thread. So where are some examples of daemon threads in use in Java? Well, a couple examples are in the Java util concurrent package, which we will cover extensively in this course because, of course, this is a course on Java concurrency. And two examples are the Java fork join pool, the common fork join pool in particular, and timer classes. And I guess, strictly speaking, the timer class isn't in Java util concurrent, but that's an example of something that can spawn a thread in the background that will go away when that thread will go away when the user threads go away. So that's the end of the overview of types of Java threads.